4.2 Reflections. Essential question: how can you reflect a figure in the coordinate plane? Can you identify lines of symmetry? In the lower grades, we call a reflection a flip. We don't want to use that word anymore. We want to use the word reflection, and we want to take a look at the mathematical process at doing this. In order to reflect, we're going to make sure that the line of reflection, that's this line right here, is acting as the perpendicular bisector from the pre-image to the image. So from the pre-image to the image, this line is acting as the perpendicular bisector. If it happens that the point is on the line of reflection, it stays on there. Let's take a look at these two examples. Here's x equal to 3, which is a vertical line, and let's go ahead and reflect it using these rules. So here's A. This has to act as a perpendicular bisector, so this is 2 units to the line of reflection, 2 units past the line of reflection, so that's A prime. B is 2 units to the line of reflections, go past that, that'll be B prime. And C is 1 unit to the line of reflection, go over, C prime. And I'm going to go ahead and draw the triangle now. That's the image, and this is the pre-image. And you can see that those triangles look like they're reflections of each other. Now with y equal to 1, I'm going to go down 2 units to the line of reflection, go past 2 units, A prime. C happens to be on the line of reflection, so that's going to be C prime. B prime, 1 unit to the line of reflection, go past it, so that's B prime. Let me go ahead and draw the image, the image of the triangle, and then here is the pre-image right here. And you can see those are reflections of each other. All right, let's go ahead and give you an opportunity to do this. Go ahead and get some graph paper out, see if you can graph this, and stop the screencast and then resume. And here is the answer. X equal to 4 is a vertical line. I graphed all the points and then use the rules of reflection to find them, the images. Here's one with y equal to 2, which is a horizontal line. Stop the screencast, see if you can do this on your own graph paper. And here is the answer. Let's take a look at reflecting across y equal to x. Y equal to x has a slope of 1. So when we make sure that this acts as a perpendicular bisector, we know the slope from G to G prime and F to F prime have to be -1, otherwise we won't have a perpendicular. So let me go ahead and take G, and I want to make sure that I have a slope of -1, so I'm going to go down 1 over 1, and that's going to be G prime, and over here I want to go down 1 over 1, down 1 over 1, down 1 over 1, and this is going to be F prime. Notice that G and G prime look like they're being bisected. Look at F and F prime look like they being bisected, and of course they're perpendicular because I made sure the slopes were what they should be. Okay, so let's start with F. It was -1, 2, and when I reflected it, F prime became 2, -1. Look at that, the x's and y's looks like they switched. Okay, let's go with G. G was 1, 2, and when I reflected it, it became 2, 1. And notice the x and y have switched places. Okay, so here are the rules for reflections in the x-axis, y-axis, y equal to x, and y equal to opposite of x. Now, this is what the book gives us, but I would prefer that you put these rules down in your notes. And I want you to notice this one. This is the one we just finished doing. When we reflect across y equal to x, we just switch the x and y coordinates. Okay, let's take a look at this problem. We're going to reflect across y equal to opposite of x. And so I'm going to write down the rule from the previous page. So y equal to opposite of x. The rule is x comma y maps to opposite of y, opposite of x. So we're going to follow that rule and graph it. We're going to take the point F, negative 1, 2, and it's going to be we're going to take this y, we're going to take this y and put it up in the x position, but we're going to change its sign. And then we're going to take this x, it says to change its sign and put it in the y position, and that's going to be a 1. Let's go ahead and graph it. Negative 2, 1, and this is f prime. Now I'm going to do g, which is 1, 2, maps to g prime. And what I'm going to do is I'm going to, the rule says to take the y coordinate and change its sign and put it in the x position. And then take the x, change its sign, and put it in the y position. So that's negative 1. And I'm going to go to here to negative 2, negative 1, and there's my g prime. So here's this image, and then here's the pre-image, and that does look like a reflection. All right, let's go ahead and take a look at graphing. I've graphed all the points, and I want to find the image after reflection in the x-axis. Okay, so x-axis rule is x comma y maps to x, and then we're going to change the sign of the y value. All right, let's go ahead and do that. I'm going to have j, and I'm going to reflect across the x-axis. 1, 2, 3, 1, 2, 3, and notice that j prime is now 1, negative 3. So the y has changed its sign. And L will be right here. So L prime will be 3, negative 1. And K will be 1, 2, 3, 4, 1, 2, 3, 4. This will be K prime. And K prime will be 4, negative 4. So each of these y values have changed their sign, and you can see that this is a reflection across the x-axis. Okay, on the next curve, on the next problem, we want to reflect across the y-axis. Now, the y-axis rule is that you change the sign of the x. So let's go ahead here. We're going to reflect across the y-axis. Here's going to be j prime. J prime is going to be negative 1, 3. So we're changing the x. 1, 2, 3, 1, 2, 3. Here's L prime. L prime is going to be negative 3, 1. Again, we're changing the x. K is going to be negative 4, negative 4, 4. And that will be K prime. K prime is negative 4, 4. Again, we're changing the x. Let's go ahead and take a look at that. Here is the image, and here is the pre-image. That does look like a reflection. Okay, so reflection is a rigid motion. The figure does not get bigger or smaller. It maintains all the angle measures and the side measures. Okay, here is an example of a glide reflection. It's a translation and a reflection, so 2 rigid motions in a row. And I'm going to go ahead and demonstrate that right here. So the first step is to take the point 3, 2, and I'm going to subtract 12. So 3 minus 12 is negative 9, and I'm going to leave the same y coordinate, which is 2. And then I'm going to go through a reflection, and a reflection means I'm just changing the sign of the y coordinate because it's in the x-axis, so that's negative 2. So negative 9, negative 2 will be my A prime, A double prime. Okay, for B, I'm going to again subtract 12, and that'll be a negative 6, and then leave the y alone. And then on this reflection, I am going to change the sign of the y So this is going to be negative 6, 1, 2, 3, and this is going to be B prime. For C, I'm going to subtract 12, that's negative 5, 1, and then I'm going to change the sign of the y value for the reflection. So this is negative 5, negative 1, negative 5, negative 1, and this is C double prime. It should have been a double prime. Okay, so you get the feeling that it slid over and then it reflected, and that's what a glide reflection looks like. All right, let's take a look at line of symmetry. There's a lot of objects that have lines of symmetry. Human beings even have it. And it's where the line of symmetry, that one figure, one side reflects over to the other side and it maps onto itself. Let's take a look at these examples. You can see that each one of these figures has a number of lines of symmetry. This is one because this can reflect over this side, and this is another one. The hexagon has, looks like 1, 2, 3, 4, 5, 6 lines of symmetry, and this one only has 1. Okay, so determine the number of lines of symmetry here. Well, you're going to have one down here, one over here, very similar to what we had before. You'll have a line of symmetry going down here, 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 and here. So there's going to be 1, 2, 3, 4. Oh, I need one more. 5. Now this one, the only line of symmetry is this one right here.